Welcome everyone, this is Jim Corkins and we're going to go through the 3.3 tutorial examples. Okay, so there's only 2 pages in this tutorial and it's very quick and easy, but the tutorial examples are understanding electric potential. Okay, and this is the first page, and these problems are supposed to be just quick and easy, and I think you have 4 of them to do. And they're all about voltage, right? So you'd learned with electric potential energy, U sub Q, that you take whatever the charge is, in this case a positive charge, positive Q, and you multiply it by voltage, right? Well, we're dealing with point charges, so this could be the K due to the other point charge divided by a distance R. Okay, but we aren't going to need to do that with most of these problems, as you just need to ask yourself, is the voltage getting more negative or more positive? So for example, if you draw, we're going to draw this blue line from the blue charge to our gray charge. So the gray positive charge is originally here, and then later on it's right over here. So this is a really far distance, right? So this is going to point out like a negative, we'll just tie a number to this. So this is like a negative 1V. However, this positive charge is so close, we could just call that a positive 2V. Okay, so overall you could see that the initial potential here is going to be a positive voltage, right? So what I'm thinking about is this. What we're going to do is we're going to sum our potentials, right? Our potential energies. And we're going to take a positive Q, multiply it by a positive 2 volts, and I'll color code it. So this is what I'm thinking of, positive 2 volts. And then we're going to add that to the positive Q in this case, which is a negative 1 volts. And we're multiplying, let me put a multiplication there, multiplying that by a negative 1 volts. So when we take a look at this initial potential here, U sub Qi, the sum of that potential, is basically going to be positive, right? Positive Q times 1, positive 1 volt, right? So this is going to be a positive potential right here. Okay, well, it looks like now it gets to where it's really close, so that will be like a negative 2V, and is further away from the positive charge. So that's like a positive 1V. So you can see the opposite is in this case. So now its potential is negative here, right? Because our voltage has dropped. So our initial is greater than our final in this first case. There's a lot of ways to do these, but it's just about estimating. Okay. Now here, this I'm going to call positive. So this positive charge is creating a positive 2 volts right on top of this negative Q. And this positive charge is creating a positive 1 volt right on top of that negative Q. Well, when you sum our potentials again, what we're going to have is a negative Q times a positive 2 volts minus, plus the negative Q times a positive 1 volt. Oh, so when you work this guy out, this is going to be negative times 2 minus Q times 1. So this is going to be negative 3QV. This one was positive 1V. Okay, anyways. So this is going to be a negative U sub QI. And when you look at this case, this negative Q just moves over here. So what you see is nothing really changes. Oh. Should be 1, right? So when we shift it over here, it's actually going to be the same number. It's going to also be a negative 3QV. So it's going to be the exact same negative, I got to use black ink, negative 3QV. And this one is U sub QF is equal to a negative 3QV. So they are the same things in this case. So this is equal. Okay? So that's your first page. Do your best on it. It's there to get you to be thinking about summing the voltages and then multiplying it by a charge. Okay? And so if you do this page on the tutorial, your conceptual understanding of potential energy, electric potential energy, will be very strong. Okay? Now let's do the second page on your tutorial, which is this one. And I think you'll also have only 4 problems. And you've done this before with electric fields, I believe. But now we're just doing it with the voltages. So on this chart, you're supposed to draw the direction of the electric field. So you're supposed to draw the direction of the electric field. You're supposed to determine whether this is going to be speeding up or slowing down. The negative charge is going to be speeding up or slowing down. And whether it's going to be turning clockwise or counterclockwise or moving in a straight line. Okay? So the electric field is pointed downwards. So I'm going to just draw a couple green arrows over here. It's downwards everywhere all through this, but there you go. The electric field is pointing down. The high voltage is 0 in this case. The low voltage is negative 50 volts, right? So the electric field is pointing downwards. Well, positive charges, if the electric field is pointing downwards, there's a bunch of negatives down here. And there's a bunch of positives up here. Okay, so this negative guy is going to want to be, it's going to be getting pushed by the electric field upwards. So it's going to have a force upwards, and so it's going to have an acceleration upwards. So I'm going to draw the acceleration vector pointing upwards right here. Okay? Now, if you remember last time, what we want to do when we draw this is keep the acceleration vector the same size or smaller than the initial velocity vector that is given right here. So this is the initial velocity. So let's add this guy to the initial velocity vector. It's about the same size, right? And if you're wondering why I'm doing that, final velocity is equal to a delta t plus the initial velocity, right? So I'm just performing this operation but with vectors. I have an initial velocity vector. Now I have added my acceleration vector to it. So the final velocity vector goes from start to finish, and label that final velocity vector. Well, if you compare the size of the final velocity vector, it is smaller than the initial velocity vector, right? So if the final velocity vector is smaller, well, you know what, I'll do it in a more logical order. So if the initial velocity vector is greater than the final velocity vector, what would you say that is? Well, this is going to be slowing down And let's determine if it's turning clockwise or counterclockwise. Well, the initial velocity vector is pointing down and to the left. And now we're going to add that final velocity vector to it. Oops. Which is a smaller vector. And you could see that it's actually making a turning motion. I bet you later on it's going to begin turning upwards, going this direction. And so if you follow that path, that looks like it's going in a circle, which is clockwise. So this is just going to be clockwise. So that's how you approach page 2 in your homework. Okay?